about 12.6, a normal distribution, and 12.7, its application, we're going to just mention a couple of things over here. This is a normal curve right here. Notice that it's nicely symmetrical with respect to this dotted line. In this location, we will position the mean right here. And then the area of the whole curve over here. And really, more importantly, the percentage of data items that are considered when you go from the left tail to the right tail. And if I were to shade everything in underneath this curve, this would represent 100% of the data value. Okay, so that's an important thing to remember. Now, because of the symmetry with respect to that line where we have the mean located, if the whole curve is 100%, then what I'm going to show you right here on the right, if I were to fill that in, that would be only 50%. And similarly, this would be also 50% of the data items we would be considering if I were to shade the other side. We have a rule called the 68, 95, 99.7 rule. And how does that work? Let's say I give you a normal distribution about whatever, in this case, test scores on a test. Okay, scores on a test. Now, you need to be given the mean, which is in this case 100, but it changes from problem to problem, and a standard deviation of 20. Once you have this information, this is how you will proceed. On the normal curve, you would position the mean right here in the middle. Now, the other thing you would do is, since the standard deviation is 20, you would move from the mean above in an above direction or a below direction by just adding every time a standard deviation. So 100 plus 1 standard deviation is 120. 100 plus 2 standard deviation is 100 plus 2 times 20. So that's 140, which is 140. Now, if you move not 1 to the right, not 2 to the right, but 3 to the right, 3 standard deviation, where are we going to end up? You started at the mean of 100 and you're adding 3 times 20 or 60. So you would get a 160 right here. Now, let's see. If we did it to the right, we need to go ahead and do it to the left. If you were to go ahead and subtract a 20 from 100, you would get an 80. If you were to subtract not just a 20, but 2 times a 20, or 40 from 100, you would get 60, and so on. If you subtract 20 and 20 more and 20 more, you'll end up at 40. Now, why do we need to label here the mean in the middle and have increments by 1 standard deviation at a time? It's because if you look at this curve, that normal curve, what happens is the following. It's like having a ruler or an axis where the mean is in the center, it's at 0. And any values that are bigger than the mean would be to the right of the mean. Any values that are less than the mean would be over here to the left of the mean. Now, all I'm saying here was a 68% and then 95% and the 99.7% rule. This is how I view it. What if I were told to consider over here how many students scored between 80 and 120? So you would have to think about what that percentage is right here between those two values of 80 and 120. Now there's a nice way to go ahead and think about the percentage. It goes by using this rule that says 1, 2, 3. So if I were to go ahead and consider the percentage of data values that are over here, 1 standard deviation above and 1 standard deviation below, between those values, you would have to go ahead and shade in all of this, and that's 68%. Now, if I were to ask you percentage of students who score between 60 and 140, because those values are exactly 2 standard deviations away from the mean in both directions, we would need to use the second percentage. 95% of the students would score between 60 and 140. And then how many would score between 40 and 160? That would be 99.7 over here percent, because we moved 3 standard deviations away from the mean.